Hello, I'm Elizabeth Guo.
I'm Minh Quang.
I'm Aryan Gajran.
And I'm Ian.
And this is our product for our CS180 team project, Ticket Hub.
First, we will be going over a preview of our products. Next, we will address the issues our product aims to resolve. Following, we will discuss the uniqueness of our solution and what makes our product stand out in the current markets. Afterward, we will give a demo of our product's functionality and an explanation of the test. Finally, we will end our presentation with a conclusion.
Imagine trying to buy concert tickets or reserve seats for any popular event, only to deal with confusing interfaces, slow responses, or systems that crash exactly when you need them. According to Vols, an Emmy-nominated anchor and reporter, 34% of Americans are unsatisfied with the current ticket purchasing options, which is a lot if you consider how huge this industry is. Our team set out to solve this problem through our product, Ticket Hub, which is a concert ticket reservation system. So my team and I noticed three main issues with the current ticket purchasing platform options. The first issue are confusing or outdated interfaces. And our product addresses this by using a clean GUI built in Java Swing. The second issue was a slow and unreliable backend. And our product addresses this by using a multi-threaded server architecture. And finally, the third issue was poor coordination between customer and admin workflows. And our product addresses this by using a structured system that separates customer and admin roles. What makes our system unique is how integrated and scalable it is. Customers can log in, browse concerts, and reserve seats easily. Admins have tools to create concerts, manage events, and oversee reservations. Our server-client model ensures that every action, such as booking a seat, is instantly reflected for all users, preventing double bookings or outdated information. And because of our modular design, new features like seat pricing tiers, filtering, or analytics can be added without restructuring the whole system. In short, this is a reservation platform built not just for today's needs, but for future expansion. And now Ian will give a quick demo of the product.
Hello, I'll be providing a demo of the product. So here's the login page. You can also create a new account. So we'll be logging into test user, which is our private testing account to test out the features. So you see this user menu page whenever you log in as a user rather than admin. You can click this button to search up available concerts. The three available ones are AJR, Taylor Swift, etc. You can then select one of them, select booking. It'll then come to this page that'll show you the types of seats available, the number of seats, and how much they cost. So you can press view my seating map, and then you can click it, and then proceed to checkout. And then boom, you get your tickets. Now after you get your ticket or reservation, you can go to view my reservation. It takes a second for it to load up because there's a lot of information being transported via the network. And it'll show you not only your seat, the time and location, but whoever's at the artist. And then you can cancel the selected reservation. Say yes. It'll be gone. Yep. And then if you go back to look at the seat, you'll see it's returned right back there. So you can log out and go to the admin page instead. So essentially what you can do is you can change the operating times and closing times of the application. Although we didn't do it, you didn't showcase it here. If you are closer or behind on the selected days, then you won't be able to do a reservation. The previous setting was 15, I put it to 7. You can change the time to 22. This works on military time, by the way. And then you can also look at a concert. Well, view all concert first. And then you can copy the name of the concert. You can say the section, and you can either lock the section or set a particular price. And yeah, that's it for the admin panel.
Alright, so now we'll be talking about some of the testing we did to ensure that our project works consistently and correctly for every user case. So for a platform dealing with financial transactions and live inventory, reliability isn't just a feature, it's a requirement. So to ensure our concert reservation system is robust, we implemented a comprehensive 3-tiered testing strategy, beginning with unit testing, followed by data persistence, and then lastly, and most importantly, concurrency stress testing. So the first kind of tests we did were JUnit Jupyter tests. So what we did is we implemented test cases for every single Java class that we implemented so that we could be confident in each one of them. And before connecting any of the components together, we could verify that each class functioned perfectly in isolation. So in these tests, we enforce input validation, constructor testing to ensure that invalid inputs like negative seat prices, invalid usernames or passwords would not reach the server and would be caught immediately. So next, we tested persistence. So we wanted to make sure that the data written by the DAOs, the data access objects, to our database, which consists of .dat files, worked perfectly. And so the phase focused entirely on these DAOs, and the goal here was to prove that our application could remember data correctly. So to do this, we wrote specific test cases to ensure that our data object classes like seat, reservation, like sale manager were serializing and deserializing properly without corruption. And then we successfully verified that the DAOs could retrieve the exact state of the database even after the application was closed and restarted, ensuring that no customer data would ever be lost and revenue wouldn't be lost to businesses as well. So finally, we performed concurrency and integration testing. This was the most critical step to ensure that the GUI on the client side would connect and communicate to the server correctly without causing errors in the database. So what often happens with high demand booking systems is that for concerts or movies that are in high demand, a lot of users will be trying to book the same seats at the same time. So what this does in threads is when the server tries to handle all of these requests coming in, it creates race conditions. And what this means is it makes it kind of like inconsistent with what seats will be assigned to what user because of how threads operate in Java. So to do this, we had to test and kind of mimic these race conditions by using multiple managers to try to test our client to see if our synchronized blocks of code would correctly stop these race conditions from happening and ensure that the server was queuing up the requests correctly. So let's say server A and server B tried to book a seat at the same time. Whoever tries to book first, their request will be accepted by the server. And let's say customer B tried to book it like half a second after, their request would be denied because of our synchronized blocks of code, making it so that only one request can be accepted at one time. So this guarantees that the client app would never display false information and our database remains stable.
Okay. In conclusion, our goal was to deliver more than a class project. We wanted to build something that mirrors real industry system. We combined clean UI design, reliable networking, a strong data handling to create a system that is both intuitive and robust. With further developments, this product could be used for event venues, theaters, sports arenas, or any business needing real-time seat booking. To wrap up our presentation, we wanted to address a few common questions regarding the architecture and business logic of our platform. The first question, why did you choose file-based architecture using DAT files over traditional database SQL? The answer is We chose Java serialization for phase 1 to prioritize rapid prototyping and object-oriented consistency. However, because we utilize the DAO pattern, our business logic is completely decoupled from the storage method. This means that as the platform scales, we can swap the DAT file implementation for a MySQL database without changing a single line of our core logic. The second question comes from the business side. How does the system handle cancellations to ensure the venue doesn't lose revenue? The answer is we implemented an instant release mechanism. When a user cancels, the system creates a historical record but immediately flips the reservation start to false. This real-time inventory update ensures that high-demand seat is immediately buyable by another customer at the moment it is released.
Thank you so much. And here are our works cited.